It's a sub.
Hey, how much? $1.
Dude, I will bring a freaking dollar tomorrow.
I'll bring like a 20 or more.
Just kidding, I have to buy it.
Very mumble.
I could
I know the bell hasn't rang yet, but problem 17, I'm going to start it. Listen closely and follow along right in the answers. Even if you didn't get the whole packet done, everybody knows that what's better than 0?
7%.
Anything. All right? So if you get this answer written down, that's better than what you had. 17, watch closely. There's no problem on the test, or on the quiz that's this hard. Ignore that stray mark. I won't talk over anybody today either. I'll just let people go sit with Mr. McKnight. You got too much to do. They say that that point M is between segment L and N. So point M, somewhere in here, between L and N. The problems on the test, you may have to draw that. Or on the quiz, you may have to draw that. All right? And then label everything. Remember, you get partial credit. Yep. You get partial credit for that. So draw it. You should be drawing it on your paper right there. Segment LM, so from here to there is x squared. MN, from here to here, again, ignore that part up there, is x squared plus 9x. The whole thing from L to N is 56. Now everybody gets confused on this because it's got the squares in it, right? That's confusing. And last year in algebra, you probably had trouble with the stuff that had the squares in it. So if we got rid of the squares, forget that those little 2's are even there. Remember, the segment addition postulate says this segment plus this segment should equal what? The whole thing, which is 56. So if we wrote it out that way, forgetting that the 2's were there, it'd just say x plus the 9x. This plus this should equal what again, Wyatt? 56. Now if I stick the little 2's back in there, because they do make a difference mathematically, now we got to solve this. When I collect like terms, what's x squared and x squared give you?
2x squared.
2x squared. Can I put this 9x with the 2x squared?
No.
Unlike terms. They're not like terms. So you just put plus 9x equals 56. Can you solve that like a normal equation?
Nope.
No. Something you might want to write down in your notes right now or somewhere on a piece of paper, somewhere where you can have it. The quadratic formula is right there. To solve a quadratic equation, you can use the quadratic formula. All right? I'm not going to use the quadratic formula, but I will give you about 20 seconds or so in your notes to write that down while I'm doing attendance real quick.
Hey, did you already get who all did homework? Are you grading homework today?
I'm collecting it.
All right, cool.
I got a calculator, by the way.
Remind me of that. I'll check them too. All right?
Except for that one.
Why?
I'll maybe not remind
Why?
Somebody else forget theirs close to you?
What?
Say you
I
got
didn't say I
one.
had mine with me. Just said I got one.
I need to buy a new calculator. I may have not broke mine.
In the city of Daytona, Gavin, Ray,
I broke
Wyatt, Dalton.
So you got that written down. You could use that quadratic formula. If you don't like doing what I'm getting ready to show you with factoring, use the quadratic formula every time. With the quadratic formula, first thing, either way, you got to make sure that this is in the right form. To be in the right form, this 56 has to be moved over here with all the rest of the terms. So we subtract 56 on both sides. When we subtract 56 on both sides, these cancel out. You're left with what on the right-hand side?
56.
0.
Zero.
On this side, can you put the 56 with either one of these two terms?
Nope.
Not like terms, so you just rewrite it. 2x squared plus 9x minus 56. Sorry, my 56 sort of. If we're going to use the quadratic formula, this 2 right here, that's what goes in place of A in that formula. The 9 is what goes in place of B. The negative 56 is what goes in place of C. Apparently Mrs. Brown taught this pretty thoroughly last year using the quadratic formula, right?
Yeah, she did.
Because everybody knows the quadratic formula, but nobody likes the factoring part. So she must have got tired of trying to teach the factoring part and just said, you know what? Let's just use the quadratic formula every time. Because is that about what happened?
I can't remember last year.
I don't like the quadratic formula. So I'll never ever use it. If you want to use it, that's fine. You plug in that number, you plug in that number, you plug in that number, do all the math. When you have that plus or minus there, that's telling you you're going to get 2 solutions. The reason you're getting 2 solutions, if you remember last year, when you graphed a quadratic equation, what you were actually graphing, if you remember, or if you were in her class for either of the last 2 years, and you did the rockets, what you're graphing is that parabola. You're graphing the parabola. And the parabola, what you're looking for on that parabola is where that parabola crosses the x-axis. That x-axis, where it crosses it, those are your solutions. Well, how many times does it cross the x-axis? Twice. Whenever you have this little 2 in a problem to start with, guess how many solutions you should have? 2. What if our exponent was a 3? Guess how many we should have? 3. If it was a 4, guess how many? 4. So on, so on, so on. I'm going to factor this. When you factor it, you look at the first term and the last term. I get my pen to write. What are the factors of 2x squared? What times what will give you 2x squared?
4. Wait.
Of course.
What times what gives you 2x squared?
X plus 2x.
X and 2x. X times previous. X times 2x gives you 2x squared. That's all. That's the only factors. That's all 2x will break into. Or 2x squared, I should say. Then we look over here, negative 56. What 2 numbers multiply together give you negative 56? Give me an easy one.
Negative 56 and negative 1 and 56.
Or 1 and negative 56, right? Well, those 2 aren't going to work. So we need some of the others also. Give me some other factors.
8 and negative 7.
8 and negative 7. What else would go along with that?
That's a negative 8.
Positive 7, negative 8. 2 and negative 28. We could keep listing factors for quite a while for 56. I'm going to tell you just because I know which ones work. That's a 0 there, not a D. What you do, you draw your 2 parentheses. These are the only 2 factors that can be the first term. So one of them goes here, one of them goes there. When you start breaking this down, and probably when you were in algebra, most of you didn't mind factoring until you got to a problem where there was a 2 or a 3 or a 4 out front. When it was just x squared, they were easy. All right? And then all of a sudden you threw in that number, and everybody wanted to use the quadratic formula instead. Negative 56, what we need is to pick one of these pairs of factors that go in here and here, but the puzzle sort of has to fit together to give us that. All right? So when we go to plug them in here, we just got to sort of guess and check. And I don't have to guess and check because I've already thought it through in my head. The way they fit in here, that's a positive 8, and that's a negative 7 over there. So we're actually picking this pair right here. And the way I know that is because to check it, what you do, you multiply the 2 that's on the ends. What's x times negative 7? Negative 7x. What's 8 times 2x?
16x.
16x. What's negative 7x and 16x give you?
Positive 9x.
Is that what we got in the middle? So that's how the puzzle sort of fits together. And that tells us this is all factored correctly.
This Brown called this foiling instead of factoring.
Foiling is what you do if you're going to expand it back out.
Oh.
All right, so if you started with this, if you started with that, and you wanted to expand it out to this, that's foiling. All right, so foiling is the multiplication style. Factoring is the dividing it up style or division style. All right, and that's why most people don't like factoring is because you have to do what? Divide. Nobody likes division.
Yeah.
All right. Now, once we have this, easiest way for me to explain this, I give you a smiley face times a triangle. And I tell you, smiley face times triangle equals 0. What can you tell me about smiley face or triangle?
One of them equals
One of them has to be 0. Now let's go back. Forget smiley face and triangle. That's me treating you like you're a second grader, right? You don't do that anymore. Let's go back up here. I got a parenthesis here, parenthesis here. We're multiplying them, and we know our final answer is 0. So either this parenthesis or this parenthesis has to be what? 0. One of them has to be 0. And that's the way we solve this, is we take this parenthesis, what's inside of it, and we say maybe that one equals 0, or what's our other equation going to be?
2x minus 7.
2x minus 7 equals 0. One of those two has to be 0 for this to work out. And what you're actually doing, you're figuring out where the x's, or where the y is 0, where the x's are, where y is 0, where it crosses that axis. How do I solve this first one? And everybody always gets confused right here.
Minus it from 0, minus 8 from 0.
And this should be the easy part, right? You've already done all the hard stuff. These are two little simple equations that you did first day of the year last year probably. Minus 8 on both sides. What's x equal? Negative 8. That's one possible answer. How do I solve this one?
Minus 7.
Minus
Add 7.
Add
I said
7.
it first.
2x equals what? 7, then what? Divide by 2, what's x equal? That's another possible answer.
Yes, it's or negative.
Now, why it's sort of right? In algebra, you just give both answers and be done. In geometry, you got to be real careful because just because we came up with an answer, does that mean it's going to work?
No.
So we take those two answers and we come back over here. And if I plug in negative 8 right there, what's negative 8 squared?
Positive.
64. So segment LM is 64.
Yeah.
Is that going to work?
No.
Why not?
This is 356, which is the.
The whole segment's only 56. Can this part right here be 64?
No.
So is that negative 8 going to work? So what's the only answer that will work?
3.5.
X equals 3.5. All right? Does everybody like the quadratic formula better?
No.
Maybe next time when we do one of these problems, say, hey, let's do the quadratic formula this time, and I'll work it out that way. Still have to have your calculator. Dalton, I know I'm not going to have to move you. I probably need to move you right now. Don't I?
Dude, I told him the same thing last year. He didn't go nowhere.
Okay. Probably I will move you up at some point because I don't like you sitting back that far away or stuff. Worries me.
He's got me.
Yeah.
Nah, he needs to be up here somewhere. Other questions on the packet? Other questions? 9. Problem 9. That's my bad. Problem 9. We're only gonna do a few because we're gonna get this quiz started. So
What?
if you got questions,
Dude, this was easy.
be ready to ask. We got this. We got this cube here, or this rectangular prism. Problem 9 says, name the intersection of plane PQO. Guess I better put the letters on here, right? I think P is right there. Q is there. O is right there. This is M, N, S, T, and R. And N, M, let's see, plane PQO, that's his front plane, right?
Yep.
So that's that right there, the very front. Can you sort of tell that that's the front of it? NMP, that's his plane on top.
Dude, it's P.
Where do those two intersect? Line PO, make sure you put the symbol on it. Line PO would work. What else do you think I'd probably accept?
Line. Or.
How about segment PO? Yeah, probably segment PO because it looks like in the picture that it starts here and stops here, right? Doesn't go any farther than that. I'd accept either one of those. What would I not accept?
Ray P.
And I'd probably accept gray PO even.
PO with that sign.
PO without a sign. If you put that,
Yeah.
no clue what you meant. So make sure on this quiz you put your symbols on everything. Next question.
13.
15?
16.
15 and 16 are sort of the same thing, so I'll only do one of those.
Yeah, you confused me when you just did one, so. Yeah.
15, segment B is between, or I'm sorry, point B is between A and C. So what do I need to draw here? Draw a segment. What's this letter? A. This one? C. And somewhere in here is what? B. Somebody tell me so I don't have to keep looking back at my paper. What did they tell us about segment AB?
That's 13
It's
plus
code.
2. 13 plus 2x.
13 plus 2x.
BC is 12.
So I label that as 12, and then they probably tell us the whole thing again, right? X plus 32. Remember, on this quiz, there's a problem like this on there. You do all this, you get a point.
There's only
Draw
one
the
total
picture and
2
label it.
points.
Huh?
There's only one total 2 points.
No, this whole thing? No, it'll probably be 3 or 4.
God dang it, dude.
Now, once I have that, segment addition postulate. Segment addition postulate says this segment plus this segment should equal what?
That same bottom.
The whole thing, right? So tell me how to set it up here.
13 plus 2x plus 12 equals x plus 32.
This segment plus why it said this segment, those two add together equals the whole thing, which is
X plus 32.
x plus 32. Another point for setting it up that way. I'm going to do this
Now you
real
can
quick and
minus
just solve it.
12 from each side?
First, you should probably collect like terms.
Probably.
So it's 2x, 13 and 12 give you 25, equals, that's an equal sign, x plus 32.
Now you can take away
All right.
25.
Now you can, I'd probably do something else before that, but if you wanted to take away 25 first, that's fine. I'd get all the x's on one side first. So you're left with 2x equals x, what's 32 and a negative 25? Negative 7? 7?
Yeah.
Plus 7?
Yeah.
Now what? Subtract x, and that's why I normally get all the x's on both sides, or all on one side first, because everybody gets confused if you don't. You forget what to do after that.
Why was the other one so much longer?
What's 2x minus x?
X.
X. What's left on the other side?
7.
7. So x equals 7. The other one was harder because it had this x squareds in it. It was a quadratic, not just a regular equation.
Can we not do one of them in the quiz because like I'm gonna fail that?
I probably won't put a quadratic on there, but there might be one like this. Is that everything?
That ain't bad.
So what's wrong with all these lines?
What lines?
No, like.
Oh, that's, because is that our
40
answer?
lines.
What did it say to find?
Oh, it said to find all the x's.
Said find x, and then what else do we have to
Solve a
find?
measure for A, B, B, BC and AC.
We gotta find all the lengths of all these segments also.
Ah,
Plug in something.
We already found X, that's one of our answers, right?
Plug it in.
Now we plug it in. So if we take this 7 and plug it in right here, you get 13 plus 2 times 7. What's 2 times 7?
14.
14 plus 13.
27.
So that's one of our answers, 27.
BC is
12.
BC, we already know, that's 12. I just like gave you a free point there.
And this will be 39.
39. Everybody agree with that?
Yeah. My number is 16.
So you got 7, those 3 answers. How many blanks were there?
4.
4. You had to find X in those 3 segments. That's why there were 4 blanks. Next question.
10.
Which one?
10.
10. 10 goes back to this drawing, right?
Dude, I can.
Name 3 lines that intersect at point S. Point S is right here.
Line FNS or SN.
This is number 10. I'm trying to fit it in here so I don't have to erase all this. Line SN,
Line TS.
line TS,
And line RS.
line RS. Everybody agree with that?
I mean, you could probably go ST and.
You could turn them around, right? All of them better have what in it though if they're intersecting at S?
S.
S. Remember, you use your symbol. 11. Is that same?
I don't really get what the.
Are points P, M, and Q collinear? What's collinear mean again? Same
Same.
line. So P, Q, and M. P,
No, same line.
Q, and M. Are they collinear?
Oh.
No.
They're coplanar.
Now, are they coplanar?
They're all on the left side.
Yeah, they're all on that plane that's back here on that side,
I
right?
thought I just had to check.
So one answer is no, the other answer is yes.
That's what I just had to check.
Everybody knows the distance formula, you can do that.
Okay, this right here.
It's right up there.
This right here is what's screwed.
Oh, you don't leave that
That
up.
is the wrap.
Oh, what track?
18 and, yeah, 18. Like the whole thing.
On 18, what you need to do
Screwed me up.
is just know that these two go together and you can't really do them separately.
I was confused.
I'll tell you this, if you were to draw that, and I'm not gonna do the whole problem of 18, but I'll show you up here real quick, and then if you have time, you can finish it out. 18, they give us this segment, and they say it's your segment. It's got A, B, C, D, oops, E. I'm gonna go by my picture because it's not drawn correctly. F and G, my points are not spaced correctly. They tell us that this whole thing is
How do they look like they're about space correct?
16. F and G are supposed to be farther apart than A and B, and mine's not.
Ah, same difference.
Then they tell us what's true about segment A, B, and segment BC. So I mark them that way. One thing. Then they tell us what's true about these 2 segments. They're congruent. Do I put 1 tick mark on each one of them?
Yeah, I put 2.
You gotta put 2. And not only do they tell us those 2 are congruent, but they also tell us
F and FG.
all of those are congruent, right? Now, in my intervention, some of them, they just thought it through, and they went, okay, if, how much would each one of these have to be for it to total up to 16?
But they didn't say all.
No, right, these 2 are congruent, and then these 4 are congruent. So, pick a number that we could put right here. 2. If that's 2, what's this? 2. Then we got 4 spaces. How much is left over for that 4 spaces out of the 16?
Like, you got 4, 6,
3.
8.
What's 16 minus 4?
It's
12. So 12 divided by 4, which is how much?
3.
So each one of those would be 3. Now could we figure out how long segment AE is if we want? Yeah, now let's make sure, because we're not sure that's right. But let's look at your friends. They said your friends, the whole thing, let's see, this is H, I, J, again, my stuff's not spaced correctly, L. They tell us that this whole thing is 11, right? Your friend's segment that they drew. And they tell us that HI is the same as your AB. So how long is it got to be? 2, hopefully. And then they tell us that IJ is the same as your CD. So it's got 2 tick marks on it, and it's going to be 3. And I think they said these others are the same, right?
Yeah.
So what would this one have to be? 3 and 3. This one? So all that add up to 11? So that's the correct way. Could we figure out how long segment HK is?
Yeah.
Yeah, and then that would answer all those questions right there. So you could do that real quick if you wanted. Make sure your name's on that packet. You're going to turn it in at the end. You're not going to turn it in right now. Notice up here after this quiz. After this quiz, you're going to turn in the quiz up here. You're going to turn in the homework packet up here. Again, anything that you have done on the homework packet is better than nothing. Better than 0. On this quiz, ignore that 2 that got written there. First thing, you're going to get with a partner. And everybody has to have a partner. So even if nobody likes Sid back there, somebody's got to pick up Sid as a partner. You're going to do these problems off of page 28 out of your book. You need your own paper, your partner needs your own paper. You can steal your partner's answers and write them on your paper, but you both need your own paper to turn in. Does everybody understand that? Don't put your both names on it, because I'll just take the first name and the other guy gets a 0. All right, so you both need your own paper. This is the key part to this. You see that right there? What's it say?
15 minutes.
You got 15 minutes. Right now it's 1:34. Add 15 minutes to that.
5, 6,
1:49.
1:49.
Go right now, get your partner and get started. You waste time, you will not get finished. I remember polygons, perimeter and area. That's what we're going to start covering right quickly, because once I'm going to switch that here in about 5 seconds. 4, 3, get it open. 2, 1.
Thanks, buddy.
Write down the title. If you don't have it written down, remember it. Memorize it right now. Polygons, perimeter, and area. What we're going to do, what you need to be able to do after today's lesson, be able to name polygons, be able to find the perimeter of polygons, be able to find the area of polygons, be able to use the coordinate plane to find those. Just make sure that doesn't affect my class any, keep it where it belongs.
It's in my pocket.
And this keeps coming.
It's just going on the seat.
I wouldn't even say ask who it was or anything. Watch closely on this, see if I can get this to work. Probably can't. Hasn't been working all day.
It needs to work.
Wyatt, do me a favor and flip
Because it's
this.
still on marker.
Flip point. Yeah, I can't. It won't switch back to pointer correctly. Flip the light off.
I can't read.
Is this September 5th?
Totally the 6th.
6.
Wow, I was a day behind.
Now, I hate doing stuff like this, but every now and then I'll throw in something like this. And I know it's childish, but watch closely, because if you're not watching, I don't think you're paying attention. We will take another quiz right after these 2 videos. And that quiz is going to ask you, what are the 3 main properties of a polygon? So that's what I would be listening for. 3 main properties of a
So
polygon.
are you?
Owen, be nice.
That's a nice shake, dude.
That's a good score.
Will you restart it?
Penn State, baby.
So you're trying to.
Why? So it's time to put some earmuffs on so when I start singing. And out.
You're all cracked out.
Just listen.
T. He's talking about polygons. Polygons.
Talking about
White bug. Why did you see SpongeBob?
Yeah, I did, dude. That was like my favorite freaking person on here.
Make sure, because I think I'm getting the quiz after this. Make sure 4 properties, 4 basic properties of a polygon. They just told them all to you that one. This one here will tell them to you too.
Gosh. Gingerbread man. This is deep.
already.
DJ But I like this one.
Yeah! Hot goes.
Alright,
Aww.
first thing. Well, I'll turn back on in a minute.
Okay.
If everybody's listening. 4 things. Let's do this though. Let's go to this and then we'll go previous. Previous. Let's go all the way back. Previous. Pointer options. And this time. 4 properties. 4 properties of a polygon. The first one told it to you best. Two-dimensional, 2D. That's one of them.
Lines that connect.
2D. Lines that connect. Both of them said lines that connect. That's sort of wrong because when you're looking at a polygon, are there lines? They're segments. Right? So both of them sort of said that wrong. Just and somebody last class said, well, but line segments doesn't really flow with the music, and that's why. And that's probably why they didn't use it. Right? So they connect. Now, we don't want to say that they connect. That's sort of two different things that we want to talk about here. What's one of them? Okay, so what the one said is the sides don't intersect. They don't cross each other. Now they do intersect, but they intersect at exactly 1 point. Not 90 degrees maybe,
Square,
but 1 point. So they only intersect at 1 point. They don't cross like this. Okay? So the sides don't cross. What else?
And they have the same number of angles as they do. sides.
Number of angles and sides. No, that's the third one. No open spaces or ends. No open parts. 2D, don't cross, no open ends. One more.
Number of sides equals neighborhood shape.
That's true, but that's just sort of telling us. That's true, but that's just sort of telling us. That's just telling us what it is.
That's what I just said.
Somebody said it.
They all have guns in them. In the name.
No what?
No curves.
No curves. There can't be any curves. No curves. Those are the four things that make a polygon. Now you guys are sort of right as far as, you know, the angles and the sides are the same, but that's not why it's a polygon. That's just what happens when it's a polygon. Alright, so those are the four things. When we get to polygon, that's sort of the definition. I'm not going to write out the whole definition. The definition's real long. You can remember those four things about a polygon. That's what makes something a polygon.
Give me a second. to write
Okay,
it down.
so if you want to be like picky about the songs, you should make your own song first, and then you can be nitpicky about everyone else's
Alright,
songs.
so that's why I'm not complaining that he said lines or they said lines.
All right, give me a second. I gotta write that down.
So, two-dimensional. Sides don't cross each other. They intersect at exactly 1 point each one.
I'm good.
No open ends. Can't have any openings.
No curves, not got
No
bends.
curves.
There's one part of it.
First one, is that first one a polygon?
Yes.
Yes. Second one?
No.
No, actually, how many polygons are there here?
Two.
There's two separate polygons. Third one?
Yeah. Yes. No.
Why not?
Because it's got curves.
It's got curves in it.
Sound like a Dukes of Hazzard.
Polygons. Are those two? Is this a polygon?
Yes.
Yeah.
Is this a polygon?
Yes.
Yeah. They're both polygons. Now they're two different kinds of polygons, and that's what I'm going to put up here next. We got. Oops. Didn't mean to do that. We got these four terms. You're going to write down these four terms. And then I'm going to give you a definition of them. Polygon, we already gave the definition, right?
What is this?
So we don't gotta write down the polygons.
Not really. If you wrote down that other stuff you just did.
Like the 41?
Yeah.
Very double bass.
This is big. Thank the Lord. Can you go back? Cause the red light is
Trying to get the music, so. Concaves. Anybody know what concave is?
Oh,
yeah, it's
like
when
where it goes
something
in
breaks
like that.
down. Like
Right.
the ends of the corner, you see how those ones go in right there?
Yeah, right.
Those are concave in.
That's concave. This
Not
right
that's
here,
where one side sticks
You know,
out.
I know that because I had a
I
roof
don't know,
concave
man.
in on me one time. That's how I know it.
and that's what it means. Now, the actual definition of concave, a concave polygon, is a polygon with
An angle over 100 or over 90.
one or more angles more than 180 degrees. How much is 180 degrees?
Straight line.
All right, so if I'm standing here and I would turn 180 degrees completely around. See this angle right here, how it's pointing in?
Yeah.
That's more than 180 degrees. That's more than just a half turn, all right? That's what makes something concave. We won't deal with concave polygons very often. This is probably the only section that you'll deal with concave is to say, hey, this is concave, this one's not.
Convex,
Right.
where it's like under 90.
Convex is the normal stuff that we deal with. So convex is the ones that we're going to deal with more often. To be convex, all angles in the polygon are less than 180 degrees. In other words, all these angles in here have to be like 150 or 130 or 20 or 80 or whatever. They can't be more than 180 degrees. So they can't be more than a straight angle. Does that make sense?
Yeah.
So if you're drawing a polygon, the normal concave polygon that I draw, that's probably the easiest, something like that. What do you notice about that angle right there?
It looks like Pac-Man.
Right, pointing in, right? That's concave. Convex, all these normal ones.
Pointing out.
All these normal ones that we normally deal with. Regular. Anybody have any idea what a regular polygon might be? All right. So watch closely. This is very, very important. You need to know this all year long because when I say a regular hexagon, you got to know that that tells you a lot of information about that hexagon. A regular hexagon, what that would mean is all sides are congruent and all angles are congruent. This is a regular hexagon, or a regular hexagon. So what do I know about all these angles?
They're all the same.
They're all the same. So if I told you one of them was 150, all of them would be 150.
So to shorten one angle, just put everything small.
Yeah, but you gotta be careful because you can't, you don't want to say this side's the same as this angle. Does that make sense? What do I know about all these sides here? They're all the same length. So if I told you this one here was 12, what would this one be? 12. This one?
12.
13.
Could you find the perimeter of that shape then?
Yes.
How would you find the perimeter? Add them all up. All right, and that's part of what you're going to do. All the sides are the same, all the angles are the same. Somebody
And the angle's like exactly 60.
on some shape, not necessarily on that one. On this picture, this isn't my good one. Somebody last year walked off with my good thing, so I had to order a new polygons picture. Must have hung it on their wall, Gavin. I don't know. I don't know why somebody would steal, because I had a big one.
It was me.
So on this, the good thing is that this one is exactly the same as that, so I don't have to teach the way that I was
It's just a whole lot smaller.
teaching it. There's one shape on this poster that doesn't fit with the others. Do I need to do the Sesame Street dance?
No.
One of these is not like the other. I know Owen knows it. He's probably
Sesame
watched
Street. I didn't even know that's what.
Sesame Street dance.
What is that?
Yeah.
What is Sesame?
My dad would always say that whenever like me and my brothers, I'm like, what is that from?
From Sesame Street. So your dad's
Is it the triangle?
So when you're not around, your dad's watching Sesame Street.
But isn't the
Or is it
rectangle
French
Do you ever come in the house and all of a sudden he turns the TV real quick? He must have been watching Sesame Street.
That's the only one I like.
Which one doesn't fit?
The triangle.
Triangle fits.
Rectangle.
The quadrilateral. Everybody watching. Why does the quadrilateral not fit with the picture?
Perfect.
It's not perfect. It's not
Congruent.
regular. It's not a regular quadrilateral. What shape would be a regular quadrilateral?
Square.
A square. Right? All the rest of these, if I'm looking at this heptagon right here, what looks to be true about all those sides?
They're all the same.
They're all the same. What looks to be true about all those angles?
They're all the
They're all the
same.
same. Every one of these is a regular polygon
Except for that one.
except for that quadrilateral. Right? So what shape should they put on here? They should have put a square on here and called it a quadrilateral because that would be a regular quadrilateral.
Technically, a rectangle is a square.
No.
Technically,
Wait
it's
a
not.
minute. Yeah.
No.
You're true.
How?
Somebody help him out. What's he saying wrong?
It's not square.
All squares are rectangles. Not all rectangles are
All
squares.
Wait, isn't that like all squares
Like
are
a
diamonds, but not all diamonds are squares?
There's no such shape as a diamond.
It's a rhombus.
Sorry.
You got burned up by it.
Draw this and write out the names.
That's my pet word.
I know.
Draw a dot.
Write out the ones you know. If you don't know them, wait till I put them up there. But
Oh,
draw
I wrote
it.
those out during the song. I wrote those out during the
Six.
song.
Can I put 3 gone, 4 gone, 5
No.
gone, 6 gone?
For those that are listed up there, you need to tell me the actual name, the proper name.
What's 11 and what's 12?
I don't know. Got all the rest of them already?
Yeah.
There you know it.
Right.
I wonder if we can figure out 12.
I got an
Oh, it starts with a D.
That's a teacher.
Yes.
It
That's
starts with a D.
that's something more.
More?
What is it?
It starts with a D.
Is it seriously?
That's what I'm guessing.
Think about how they gave them the name.
It says.
Where did the name triangle come from? Somebody seen it one day and said, "Oh, that looks like a triangle."
Yep.
Tricycle.
3 angles.
Got
Tricycle.
3 triangles. 3 angles. That's where it came from.
I'll be completely honest, I'm just guessing. I'm
So,
Walker.
so let's think about a 12-sided.
12 ago.
What is that, an N at the bottom?
Yep.
thinking of the
Wow.
known quality twins and whatnot. Except for twins, parents, and this.
Well, no, that's not thinking of it.
Sid was real close a few minutes ago.
What you said.
12 gone.
That's it.
3-sided. What's a 3-sided?
Triangle.
Triangle. Now, I was watching the show last night, and this made sense for this next one. Because a lot of math books now don't call this next one a quadrilateral. Because all the rest of these, like a triangle, why is it called a triangle?
Try.
It's got 3 angles.
They call it a 4-angle.
So this one should be a 4-angle, right? That would make sense. And that show even pointed this out, that a lot of things in our English language that we think is correct make no sense.
Wait, so
And this is one of them. Quadrilateral doesn't really make sense because if we're going to say 3 angles, why not say
This ain't
4
quad
angles?
forward.
Quad means 4.
Like
Wait,
the
But
same thing.
quadrilateral. So what's quadrilateral mean? 4 sides. So
So what you're saying is I can call like a 5, like 5, 5 angle.
no, you need the prefix and then angle. Quadrilateral. Some new books call it a quadrangle too.
That's weird.
So quadrilateral or quadrangle. Either one of those is correct.
Quadrangle.
Decagon is 10.
Now 5 and 6 and all these, they don't actually go off of that. They go off the gon part of it.
Deca.
What's the prefix that means 5? Penta. So for 5, it would be pentagon. What's the prefix for 6?
Hex.
Hex. Hexagon. For 7? Hept. Now, you don't see heptagon very often anymore because there's another prefix that means 7. Anybody know it? Septagon.
Decepticon?
Septagon. Septagon. Probably will never ever see a heptagon. You'll never see a heptagon. That's
I'll
not
teach
one
my
that
child
uses.
when they get older. That's a triangle. There you go. That's all you need to know. It's unnecessary.
8 sides. Octagon.
Just like Conor McGregor fights in.
9 sides. Nonagon. 10 sides.
Deca.
Decagon.
You could just call this whatever you want. So the next one.
Not really.
It's like a 12 gun.
That's what I said.
See, I won't accept that though because I'm getting ready to tell you a proper name.
Hold on.
I think undecagon, because that's the only thing I
I forget.
Is it
I knew you wouldn't get that far.
Tractagon?
10 is D8.
D8, yeah, D8. I don't know.
Now, see that would make sense, right? The bad thing is these aren't Spanish prefixes. They're Latin prefixes. Look at this prefix. What did that mean?
Deca.
Deca,
10
what's
years.
2?
Tuca.
Think about music.
Dose.
Music.
Do. Do is 2.
Doka.
So guess what that is?
But you said they weren't
Don't-
Spanish.
That's not. That's Latin. Do is Latin. And it just happens that the Spanish came from there.
What was I thinking?
That's a many-sided, three-sided figure. Or three-dimensional figure.
What's the
I
N
have
stand
no-
for?
Oh, God.
The N.
No sides.
Dodecagon. It's not hard. Dodecagon.
The N is no sides, so not a polygon.
Enough. Getting too silly. On the inside, we're not going to deal with these a lot of the times. A lot of times they'll give you something like a 26-sided figure. So if you have a 26-sided figure,
It ain't no running.
you're not going to remember all the names. Even though we could give every one of them a proper name, it's not going to help because you're not going to remember them all.
So
These I expect you to remember. For this one, when you get up more than 10 or 12, you just write the number and gone. That's what you do on this last one. So anything that's more than 10 or 12, you just write whatever the number is, gone. That way you don't have to have proper names for all of them.
Why don't we just do that with everything?
Exactly.
You could, but the bad thing with that is sometimes you need those proper names. All right, go ahead and write this down, a triangle. These are the two formulas for a triangle. Perimeter and area. Write quickly because we're going to move quickly because you should already know this.
It's on our paper, right?
Yeah, exactly.
Whenever we're dealing with area, what units does the area always have to be in?
Square.
Square feet, square meters, square inches, whatever. It's always got to be something squared. Something squared. When you're dealing with perimeter, what's the units got to be? Just regular. Feet, meters, inches, miles, whatever. So perimeter is always just regular units. Area is always square units. The reason area is square units is because what you're doing is you're taking this shape and you're splitting it up into little squares and you're counting how many of those little squares fit inside of it. That's what area is doing. All right? With the triangle, 1/2 times base times height. Anytime you are given a triangle, you're probably going to be given something like this. What's that symbol?
Oh, right.
Square.
It's a right angle. All right? That tells you there's a right angle. You find that right angle, the side that that right angle sits on is the base. The side that goes up and down next to that right angle is the height. So the height's always going up and down next to that right angle. The base is what it sits on. What if I turn that triangle and I turn it upside down like this?
Same thing.
Does it matter if this is the base and that's the height? No, it doesn't matter which one's which. So base and height, interchangeable. Okay? So don't let that confuse you. 1/2 times base times height. A lot of you probably want to take this 1/2 and change it into what? 0.5 times base times height. You might want to write that down. 0.5 times base times height.
That doesn't make as much sense to me as
See, it doesn't make any sense to me either, but there's going to be about half of the people in here who are going to
I like decimals more than fractions.
not like the fraction, and as soon as they see the fraction, they give up on the problem.
So easy with the fraction.
It is. It's not hard. Next, square. Perimeter of a square. This is the formula for perimeter of a square. This is area of a square. What's that S stand for?
Side.
Side. S stands for the length of a side. Length of one side. Length of one side, right quickly. What do we know about a square?
And everything congruent.
All the sides are the same. And I put those tick marks on there to show us all those sides are the same. What do we know about all the angles?
Congruent.
They're all congruent. They're all what?
90.
90 degrees. So all the sides are the same, all the angles are the same. Then a square, another name for a square is a what?
Quadrilateral. Quadrangle.
Quadrilateral will work, but put another word in front of it.
Quadrangle.
Wait.
Foregone.
What's special about it?
It's regular.
It's regular, thank you.
Quadrilateral.
It's a regular quadrilateral. Next one, a rectangle.
It's
Rectangle,
not regular.
perimeter. What's this letter stand for? Length, width. Length, width. Now, another formula for area of a rectangle could be base times height. Either one of those would work. Write down those formulas. Length times width is area. Perimeter is 2 times length plus 2 times width. This formula right here, I never ever use it. Because what's the easiest way to find the perimeter of a rectangle?
Add up all the sides.
Add up all the sides. It's easier that way than trying to remember that formula, right?
Just write width or base times height.
That's probably that one, huh? Yeah. You should already know all these that I've covered so far.
I don't get the perimeter.
These formulas you already have. If you need them again, that's up to you. You're going to use these. Wyatt, shh. Move you out in the hallway. We're going to use these on the homework. It's going to tell you triangle ABC. It's going to say point A is 2, 7. Point B is 3, -2. Point C is 5, 4. Well, you're going to have to graph those, graph them on here, and then have your triangle. Can you just count and find the lengths of those sides?
No.
No. What do you have to use? The distance formula. Use the distance formula, find this length, and this length. And once you find all 3 of those and you want to find the perimeter, what are you going to do with all 3 of those? Add them all up. So that's what you're going to have to do on your homework. They're not just going to give you some triangle like this and say, what's the perimeter? They expect that you could have done that about 6 years ago. They want you to be able to use what you've learned with the distance formula and find the perimeter. Let's just do these 2 sentences here. Complete the sentence. The perimeter of a square with side length S is what? P equals what?
4x.
4S. What formulas can you use to find the area of a triangle on a coordinate plane? I just told you. Distance formula.
Yeah.
Distance formula. We're skipping that, skipping that, skipping that, skipping that, skipping that, skipping that,
Dang, you got a lot
skipping
of
that. Write down this. Let's see here. This is your assignment. We were supposed to do these together.
You just marked it out. Yeah, I say I'm gonna take a picture.
I'll tell you what. Do all of it, but listen to me. I won't throw a big fit if you come in here and you've skipped 8 or 10 problems in here somewhere. All right? But try them all. All right? Try it. You can skip some. So if you got a problem, if number 8's the same as number 9, maybe skip number 9. Or same kind of problem. Does that make sense?
Got it.
This is over.
Well, that's your class is going.
All right, on this end class assignment. Number 1, complete the sentence. The perimeter of a square with side length S is P equals the formula. Is P equals. I forgot to put my 4S. 4 times S. What formulas can you use to find the area of a triangle in a coordinate plane that's on a graph? You're going to use the distance formula. Distance formula. So you have to use that distance formula to find the length of each side. Then worry about adding them up to find the area or I'm sorry, using the formula to find the area or adding them up to find the perimeter. The next one, 3, 4, 5, and 6. Three, 4, 5, and 6, they want you to name the polygon according to the number of sides. So you just count up the sides, and they want you to tell whether it's concave or convex. So on this first one, count sides 1, 2, 3, 4. So it's a quadrilateral. Quadrilateral. And then you see this angle right here is more than 180. So it is concave. Number 4, 3 sides, so triangle, that one's pretty easy. Triangle, and it's convex. Ignore that stray mark. Next one, 1, 2, 3, 4, 5 sides. It's a pentagon, and it is convex, because all these angles inside here, they're all less than 180. All less than 180. Next one, we'll count the sides. 1, 2, 3, 4, 5, 6 sides. So it's a hexagon. And it's got an angle more than 180. So it's concave. Concave. Next, number 7, number 9. Number 7 says, find the perimeter of the polygon with the given vertices. So all I'm going to do, see what our numbers are here. I'm just going to try to draw a little one here. We go up to 4, so for number 7, I'm just going to draw X and Y axes here. We got the point 2,4, so to the right 2, up 4, that's G. To the right 2, down -3, that's H. To the left 2, 1, 2, down 3, 1, 2, 3, that's point, looks like a J, I think that's a J. And then -2, 4, so left 2, up 1, 2, 3, 4, that's K. So we're looking at this shape. We're trying to find the perimeter of it. Nice thing about this is we don't have to use the distance formula because each of these segments is either vertical or horizontal. So all we have to do on this one is just count. Count the spaces on this one, 1, 2, 3, 4. So that's 4 units long. Count on this one, 1, 2, 3, 4, 5, 6, 7. 7 spaces, 7 units long. Bottom one, 1, 2, 3, 4, that's 4 units long. This side over here, 1, 2, 3, 4, 5, 6, 7. Add them all up to get the perimeter. 4 plus 7 is 11, plus another 4 is 15, plus 7 is 22. So the perimeter of that shape is 22. That's number 7. Number 9, I'm going to do down here, I'm going to draw an X and Y axes right here in the corner. This time the first one is -2, 4, -2, up 4, that's U. Next point is 3, 4, 1, 2, 3, 1, 2, 3, 4, that's V. And then W is 3, -4. 1, 2, 3, 1, 2, 3, 4. That's W. So now we have this shape. That's our triangle. 1 second. So again, nice thing about this triangle, UV, this segment up top, UV is horizontal. All we got to do is count. 1, 2, 3, 4, 5. So that side's 5. VW, that segment, that side of the triangle, is vertical, so all we got to do is count. 1, 2, 3, 4, 5, 6, 7, 8. So So it's 8 units long. UW though, we can't just count. UW, we actually have to use the distance formula. And we know U is negative 2, 4, and W was 3, negative 4. So we're going to use the distance formula to find the length of it. We take our x's are negative 2 minus 3. That's our x's. Our y's for U and W are 4 minus a negative 4. Change it, both those to plus there. Negative 2 minus 3 is negative 5. Four plus 4 is 8. We square each one of those. Negative 5 squared is 25. 8 squared is 64. Add those together. You end up with 89. Then you got to take the square root of that. You grab your calculator and you take the square root of 89. And I get about 9.4. About 9.4. So UW, this side, is about 9.4. Then all we're going to do is add up that 5, that 8, and that 9.4. 9.4 plus 5 plus 8. Use your calculator again if you need to. So the perimeter of this shape is about 22.4. That's for number 9. Number 11, find the perimeter of that shape. They actually had the coordinates on there for you. I didn't put the coordinates on here. You could do that. Coordinates of L there look like 1, 4. Coordinate of M, coordinates of M are 1, 2, 3, 4, 4, 0. Coordinates of N, 1, 2, 0. And the coordinate of P, the coordinates of P, looks like 1, negative 1, sorry. Left 1 and down 2, so negative 1, negative 2. To find the perimeter of this, we're going to have to use the distance formula on all 4 sides. And I'm just going to do that real quickly. You can write on your paper and use the distance formula. I'm not going to write every single one of them out up here. I'll do LM, then segment MN, and segment NP, and segment PL. Those are the 4 segments. We need those 4 lengths. I'll work one of them out, and the others I'll probably just sort of do in my head. You can work them all out. Let's start with LM. We're doing the distance formula for LM. Remember, your distance formula looks like this. Looks like that every time. This time, L and M, these 2 points. Our X's are 4 and 1. 1 and 4 actually, but I turned them around. Then our Y's are 4 and 0. Do some of the math here. 4 minus 1. 4 minus 1 is 3. 3 squared is 9. 4 minus 0 is 4. 4 squared is 16. Add those 2 together and you end up with 25. Don't forget you still have to take the square root of that, so that is 5. So segment LM, the length is exactly 5. That side right there is exactly 5 units long. Segment MN, we can just count. It's horizontal, so all we got to do is count. MN is just 2 spaces. The other 2 we use the distance formula on, and I'm just going to I'm not going to write it all out like I did on this one. Let's see, for NP, our X's are 2 and negative 1. 2 minus a negative 1 is 3. 3 squared is 9. Our y's are 0 and negative 2. 0 minus a negative 2 is 2. 2 squared is 4. 9 plus 4 is 13. So we need to take the square root of 13. Grab your calculator. Take the square root of 13. That gives us 3.6. So that segment NP is 3.6. That goes right there. PL, I'm going to do the same thing for PL. Just looking at it, 1 minus a negative 1 is 2. 2 squared is 4. 4 minus a negative 2 is 6. 6 squared is 36. 4 plus 36 is 40. Got to take the square root of 40, so grab your calculator, second square root 40, and you get about 6.3. So that segment is about 6.3. We want to find the overall, the total perimeter. So all we're going to do is add all those up. So I do 6.3 plus 3.6 plus 2 plus 5, and I get 16.9. So the perimeter of that shape is about 16.9. It takes a little work, but once you get used to doing the distance formula over and over again, it shouldn't be all that difficult. Next one, find the perimeter of this one. Nice thing on this one, we look at this segment right here. Looks like it's a vertical segment, and it's 2 units long. That one's horizontal, it's 2 units long. That one's vertical, it's 2. That one's horizontal, it's 2. And I'm going to tell you this, that these two right here, I don't know if the book told us this or not, but those two are congruent to each other. So we find one of them, and we'll know the other one. And the way we're going to find them is just by using the distance formula. The coordinates of this point right here is negative 2, 2. Coordinates of this point down here, 0, negative 2. And again, I'm not going to write all this out for this one. I'm just going to sort of do it in my head. 0 minus a negative 2 is 2. 2 squared is 4. Plus 2 minus a negative 2 is 4. 4 squared is 16. Add those together, you get 20. You want the square root of 20, grab your calculator, second square root 20, and you get about 4.5. So that segment's about 4.5. Well, if those two are congruent to each other, that one's 4.5, then this one's 4.5. And you can't just assume that they're congruent, but I'm telling you that they were congruent to each other in this case. Sometimes you might have to go through and do all of it. Then we just add up all these sides. First two, I'm going to add the 4.5. 4.5 plus 4.5 is 9. Then you got 2, 2, 2, and 2. There's 4 2s there. That's 8. 9 and 8 give you 17. So the perimeter of that shape is 17 units, whatever the units happen to be. Next one, find the area of this shape. So we got to graph this shape. I really don't need this whole big graph. So I'm just going to draw my X and Y axes right here. We go 3, 1 is E, over 3, up 1, that's E. 3, negative 2, 3, negative 2, that's F. And negative 2, negative 2. I didn't give that, I'm sure that's supposed to be a G. I forgot to stick the letter in there. So we have this shape, and we're trying to find the area of it. Well, that shape happens to be a triangle. Formula for area of a triangle is 1/2 times base times height. The base and the height are always given where there's a right angle. Well, if this is a horizontal segment, this is a vertical segment, that has to be a right angle right there. So this one is your base, that one's your height. And the nice thing about these is, that's horizontal, all we gotta do is count. 1, 2, 3, 4, 5. So that's 5 units long. This one's vertical, all we gotta do is count. 1, 2, 3. So our base is 5, our height is 3. We just plug into this formula. 1/2 times 5 times 3. you don't like the 1/2, change it to 0.5. 0.5 times 5 times 3. Doesn't matter how you do it. 5 times 3 is 15. 0.5 times 15 is 7.5. So the area of that shape is 7.5 units. Next one, find the area of this shape. Just look at our numbers here. I don't really need the whole grid again, so I'm just going to draw X and the Y axis here. -2, 1, that's N. P is 3, 1. Q is 3, -1. R is -2, -1. Hopefully if you look at this shape, you realize it's a rectangle, and the formula for area of a rectangle is just length times width. That's a W. Or you could use base times height, either one. Nice thing about this one again, that length is horizontal, all we gotta do is count. 1, 2, 3, 4, 5. So it's 5. The length or the height is vertical, all we gotta do is count. 1, 2. So all we gotta do here is 5 times 2, tells us the area of that shape is 10 units squared. Whatever the units happen to be, they have to be square units. Again, that's your assignment. I'm going to go over the quiz on this video, so that's the assignment. I'm going to go back and go through the quiz. All right, on this quiz, problem number 1 asks you to name just name 4 points. Doesn't matter what the 4 points are. So I'm just going to pick point H, point G, point F, and point B. You could have named any of those points. Doesn't matter. Number 2 says name 3 collinear points. Collinear, remember, means on the same line. Well, you could name these 3 right through there. You could name these 3, they're all on the same line. You could name those 3, they're all on the same line. So it doesn't matter. I'm just going to pick C, D, and E, those 3 points. They're all collinear, they're on the same line. Number 3 says name 2 lines. Pick any 2 lines you want. Just remember to use your line symbol. I'm going to pick line HF and line AB. So all kinds of different lines on there you could have picked. Those are the 2 I happen to pick. Number 4, name 3 coplanar points. Coplanar means points on the same plane. On the same plane. Well, all they wanted was any 3 on the same plane. You could have picked any 3 on this green plane, any 3 on the blue plane. I'm going to pick the blue plane over there and say point K, it's on the blue plane. Point D is on the blue plane. And point L, even though it's on the green plane also, it's also on the blue plane. Number 5. Name the plane that is shaded green. To name the plane that's shaded green, that's this plane over here, we just pick any 3 letters on that plane that are non-collinear. So we can't pick H, G, and F. We can pick H and G, but then we got to find some other point that's non-collinear to those 2 to finish it out. And it could be any of those 3 over there. So I'm going to say plane HGA. Just 3 letters. And you could, there's many different ways you could name that. Number 6, give 2 names for the plane that is shaded blue. So we want 2 names for this plane over here. Again, 3 letters, plane. We don't want them to be collinear letters though. So I'm going to do plane A, L, and K. A, L, and K. And then we could pick plane C, B, and D, as long as they're non-collinear points. Number 7, name 3 line segments. Even though this is a line in the picture because it's got arrows, we can take part of it and make that a line segment. So I'm going to use line segment HG, got to make sure you use your symbol. Line segment GF, and then we could pick any other one. I'm going to say line segment CD. 3 line segments. Number 8, name 3 rays. We could take all of these that we just named up here, and instead of naming them line segments, we could make them rays. Remember, ray just means it goes on in one direction forever. So you could use that. Now there's plenty of other rays or line segments on there you could have used. Next, draw ray, QR, and line QS. So I'm going to draw a line first. Put a Q right there. Put an S right there. That's line QS. For ray QR, we know that the ray starts at Q, so we already got point Q. So the ray is going to come out maybe that way. It could go up also, and it's going to have point R on there. That's your drawing. Number 13 said, find the length of segment AC. On 13, I think it goes ABC that way, and then this one it goes A, then C here, and B there. They want us to find AC. Well, on this one, all we got to do to find the whole thing is add those 2 up. So for number 13, it's 29. Just add them together. This one, AC is just from here to here. To find it, we take the whole thing, which is 62, and we subtract off that part. So we end up with 51. So segment AC is 51 on that one. Number 16, 15 and 16 say, find the coordinates of the midpoint and the distance between the 2 points. So we're actually going to use the midpoint formula and the distance formula. I'm not going to do any graphs on this. You could have graphed it. That's why I put these on here. If you wanted to see it, that might be helpful. All we really have to do is use the midpoint formula, which is adding the x's together, dividing by 2, adding the y's together, dividing by 2. That's going to give us the midpoint. And then the distance formula, which is the formula that looks like this. X minus X, Y minus Y. So we're just going to use those 2. And I'm going to do a bunch of it in my head. For the midpoint formula, the x's for my first 2 points here are 4 and 2. So I just stick in 4 plus 2 divided by 2, that's the x's. For the y's, it's 3 and negative 3. So 3 plus a negative 3 divided by 2. 4 plus 2 is 6. 6 divided by 2 is 3. 3 plus negative 3 is 0. 0 divided by 2 is 0. That's the midpoint. That's half your answer. Then you got to find the length of that same segment from 4, 3 to 2, negative 3. And if you wanted to look at it, you could draw it on here. Over 4, up 3, that's J. Over 2, down 3, that's K. We're looking at that. We just said that the midpoint is 3, 0. So it'd be somewhere right in there, which it looks like my segment is drawn way, way off. I do something. I didn't count right. 1, 2, 3, 4. The point should actually be there. So the midpoint should be right there, which it looks like it about is. Now on the distance formula, we want to actually find the length. So we're just going to plug into this formula right here. And again, I'm going to do a bunch of this in my head. The x's are 4 and 2. 4 minus 2 is 2. 2 squared is 4. Plus the y's, 3 minus a negative 3. That'd be 3 plus 3, which is 6. 6 squared is 36. Add those together, it's 40. We got to find the square root of 40. We just did this a couple minutes ago, but I don't remember what it was. So second square root, 40, and I get 6.3. Those are your 2 answers for number 15. Number 16, for the midpoint, negative 4 plus 5 is 1. 1 divided by 2 is 1/2, or 0.5. So that's the x-coordinate. Y is 3 plus a negative, or 5 plus a negative 3 is 2. 2 divided by 2 is 1. That's your midpoint. Distance formula, using the distance formula, we plug in -4 and 5 for the x's. Plug in 5 and -3 for the y's. And again, I'm going to do a bunch of this in my head. -4 minus 5 is -9. -9 squared is 81. 5 minus a -3 be 5 plus 3, which is 8. 8 squared is 64. Add those two together and you get 145. You want to take the square root of that, grab your calculator, square root 145, and you end up with about 12.0. That's the length of the segment. That's the midpoint of the segment. Next, they want you to name the bisector. Well, the bisector is what splits it up into these two equal parts. The only thing that could be the bisector this time is point M. We don't have a line or anything that's bisecting it. Then they want us to find the length of segment RS. Well, if we know that these two are congruent, the equation we're going to set up this time, instead of saying this segment plus this segment equals the whole thing, we know that they're equal, so we're going to say this segment equals that segment. So 6x minus 2 equals 3x plus 7. Subtract 3x on both sides. You end up with 3x minus 2 equals 7. Add 2 on both sides. You end up with 3x equals 9. Divide by 3. You end up with x equals 3. They didn't ask us to find x. They asked us to find the length of RS, which is this whole thing. So I just take that 3 and I plug in here. 3 times 3 is 9. 9 plus 7 is 16. So that side's 16. Well, that means this side's got to be 16. I want the whole distance, so I add those two together, and I get RS equals 32. Those are the two answers you should have on that one. Next one, the baseball diamond. How far is it from home to second? I know exactly, but what they're using here, they said that each block counts as 15 feet. They're not going to be exact. And if we look at this from home to second, like that, these two distances they're claiming are the same, and they're not actually, but we're going to go with what they say. If you knew a mound, home to the mound, if you knew it was 60 feet, 6 inches, because that's a normal baseball field, I give you credit for that one, even though that's not the answer we're going to come up with from their picture. So on this, to find the distance, actually they didn't tell you that this was 15 feet. I found it was 15 feet because if I go down here, they told us that was 90 feet. And I knew that 1, 2, 3, 4, 5, 6 blocks. So I took 90 and I divided by 6, and that's how I got each block was 15 feet. So each of those blocks is 15 feet. But we can't do that going across this way. We just have to figure out how many blocks it is going from here to there. So home to second, we got to use the distance formula. Our x's are 6 and 0, so 6 minus 0 squared plus our y's, which is 6 and 0, 6 minus 0 squared. 6 minus 0 is 6, squared is 36. 6 minus 0 is 6, 36. Add those two together, you get 72. And you still got to take the square root of that. So second, square root, 72 on my calculator, and I get about 8.5. Well, that means it's about 8.5 blocks. So I take that 8.5, and I times it by the 15 feet, which I figured out is each block. So 8.5 times 15, and I get about 127.5 feet. That's the distance from home to second. Now, if we're looking at this picture, the mound is actually the midpoint between home and second on their picture, So we could just take this 127.5 and divide it by 2 and get 63.75 feet as the distance from home to the mound. And that's not too far off from the actual distance, but it's not exactly right.